Hi, in this tutorial, I'm going to cover some synthesis basics in SuperCollider. I'm going to be focusing mostly on modular or subtractive synthesis, and maybe covering a few basic concepts and principles within the SuperCollider programming language. All right, so the model basically I'm going to use, now there's lots of different ways to do things in SuperCollider, but the model basically I'm going to use is the synth-def model. All right, so I'm going to start with a basic syntax of the synth-def. And the way I like to describe the synth-def is in programming speak, is it's sort of like a mini class or a quickie class. So basically, if you think of a class as a template or a model or a mold from which you can make lots of different things. So if you have like a Frankenstein mold, you can take that mold and then pop out a bunch of different Frankensteins. And then there are certain things that you can change about each instance, we'll call them, of Frankenstein, or each Frankenstein monster. So you can maybe change the colors. You can have green ones, red ones, but they're based on the same basic mold. Well, the synth-def works very much the same way. So it's like having a synth. Well, basically it's what it's called, a synth definition. It's like having a digital synth programmed inside your server, or or maybe like a synth patch is another way to look at it. Okay, but to get our synth-def going, we just basically go def. Okay, and then you use these brackets to declare scope. So everything within these two parentheses are part of your synth-def, and then you do .add, and this adds it to a server. Now I'll go into a little bit of explanation about the SuperCollider server and SuperCollider language side. Basically, this stems back to the origins of computer music and the developments that Max Matthews made in his what we call music and languages. So basically, Music 1 through Music 5. And he very rightly came up with this idea that you would, a lot of the sort of hard-coded, computationally intensive things that a lot of digital audio requires would be taken care of offline. Well, not offline, but taken care of by another entity of the computer, and which in this case we call the server. And Max would bundle up functions such as creating an oscillator. Well, he would sort of hard code all the bits that were would make a digital oscillation happen, and allow you to control things that made sort of more musical sense, like frequency or amplitude, these sorts of things, and then create, much in the way, say, Robert Moog or other people like these developed in analog modular synthesizers. He did the same thing on the digital side, things like envelopes or filters and then allowed access to these things in a more intuitive manner, which he called the score side. And so SuperCollider is very much divided in the same way. So on the score side, you can think more in sort of musical terms, in terms of durations, in terms of pitch, things like that. And on the server side, that does sort of the mathematical computations that you might need on that side. Okay, well, to carry on, basically this add sends your synth-def to the server. So basically it's stored there for the duration of your SuperCollider session, and you can call on it and you can do different things. Now, James McCartney, in developing SuperCollider, developed this sort of system to where you can quickly create a synth definition, and then there's already sort of a built-in syntax with which you can use to manipulate the synth definitions. But I think the salient point, or the important point, is to understand that this is just a definition. It doesn't actually exist. It doesn't actually, well, exist, but it doesn't actually make sound. You're defining something on the SuperCollider server, which later on eventually you'll use. So it's like a mold or template or blueprint, which you can call upon to create things later on, or sound-making objects later on, which we'll call instances or synths. So you have your synth definition, then you have your synths, which are objects that actually make sound. Okay. So the first argument, and you'll notice the IDE, the SuperCollider development environment, fills in things. And so synth-def, again, is part of this syntax that was built in to SuperCollider language side. And it takes a number of what we might call arguments, or various things that we can give it to it that will sort of define it and let it function based on your specifications. So the two main ones we want to worry about here are the name and the UGen graph function, which probably don't mean that much initially, but we'll just accept for now and use those. So we give our synth-f a name, and that's important because we'll refer to this name later on to use this definition. And in SuperCollider, use this backward slash as to denote symbol. So, and that's just basically a string without any spaces. So we'll call this synth, synthy, something like that. Okay, and then a comma, and then it brings me to my next argument, which basically the heart of your synth-def. It's a function, and functions in SuperCollider appear in these curly brackets. And so I've opened curly bracket, closed curly bracket. Everything with those curly brackets will basically be my sound making machine. All right. So the first thing usually I would put in the synth-def is its output. We use what's known as a UGen. And again, UGens are these things, like as in a modular synth, modules that are sort of compiled bits of code that do specific things, and we can just call them by these names, usually with a capital letter in SuperCollider. And you have .ar and .kr. AR is audio rate, meaning you're going to work in at 44,100 times per second or whatever the sample rate is. And KR would be a much slower control rate for modulating, for sending control signals, and that just sort of to make the server more efficient. So in this case, out.ar is a unit generator, which is our output to the world. It's our basically digital audio converter, and it takes a couple arguments. And you see when I open the parentheses, it's got my arguments there. And it's going to take the bus, which is the channel it's going out. And SuperCollider has a multiple bus system, so that you can send it to buses which are go out to the world, which are part of your sound card. So if you have an 8-channel sound card, the first 8 buses will be going out to your sound card. And then it has a number of private audio buses which just sort of go out to the ether, but you can call upon later on and bring it back into your main mix. So in this case, I'm just going to send it out to 0, which would be my left channel. And the channels array basically is referring to whatever sound making thing you have in your synth-def, which is going to go out channel 0. So I'll just leave that blank for now. Okay. And that brings me to the next bit. A next layer of things that you might put in the synth-def would be variables or arguments as well. We'll get to arguments later, which is more of like a specialized kind of variable. But vars would be use the word var, and it turns blue, dark, bold. You see that? And basically, you can use variables within your synth-def to help you sort of clean up your code and ways to reuse bits of code in there. So I'm going to create a var, and I call it synth. Okay, and then now this is just there. It's a word that can be used, and I can assign things to that word. And I know that eventually I'm going to send this synth out. This is going to be the thing that I want to send out. This is going to be my audio making process. Okay, so I'm going to send that out. So out now has the channel that it's going out, and then synth, which is the sound making object that I'm sending out. Okay, and then finally we can just define synth by assigning something to it. So synth is going to be assigned to, and then we'll use another unit generator, a sine oscillator, and .ar, and we're going to use audio rate. And then this UGen has its own set of arguments as well. But if you don't put any arguments in, if you just do that, it'll just use the default arguments there, which are frequency equals 440, phase is 0, multiplier 1, and add 0. So in this case, if I wanted to change the frequency, I can maybe say put a frequency in as 200. Now, the way all the unit generators work in SuperCollider, the way the arguments work, is you can put them in order. And if I do that, I can have initial phase of 0, I can have a multiplier of 1, add a 0. And even though there's not, if it just goes in order, it just knows that that's my frequency, that's my phase, that's my multiplier, that's my adder. If I want to go out of order, I can do that. And in that case, I would have to designate the argument name. So if I don't care about the frequency, keep it at 440. If I don't care about the initial phase, 0, I can, for example, go MUL, and then specify the multiplier, say 0.5, and that'll just make it a bit quieter, something like that. Okay. And in just so you understand my standard practice here, just for clarity's sake, I am going to from now on just specify all the I'm gonna label every single argument going out. Well, maybe not without here, but I could do that as well, just so it's more clear and we can see that what happens in the code. Okay, so in this case, FREQ, if I do that, and let's just make instead of the default 440, let's just make it 200 there. Okay, so now I'm going to boot my server, and you can either do that by hitting Command B, or you can do s.boot. Okay, and I'll go ahead and do that. And then I'll send my SynthDef. Now I'm going to do this sort of time-saving device by putting that within another set of brackets, which is another scope. And I'll go ahead and send that SynthDef. Once I hit Command Return, it's going to send the entire SynthDef there, and you can see a verification here, a SynthDef, in your post window. And now it's ready to go. Now you notice there's no sound happening, but in fact, again, it's just a mold. It's just a blueprint that's out there that's to be used anytime. And I think this is sort of an important concept. Sometimes people struggle to grasp this, just this idea that this is the blueprint, but in fact, later on, we're going to create instances, just like if I had a Frankenstein machine, I can create a bunch of little Frankensteins, and I can change various things about those things. So in order to create an instance, we're going to use the synth method, okay, synth, and usually you assign this synth to a variable, and then you can manipulate that variable later on. So in this case, we'll just use a. Now remember, in SuperCollider, all the single letters are already global variables. You can use them that way as long as it's a single letter. Some are reserved, like S, for example, for the server. If you want to use more than a single letter, say AA, you need to either put it in some kind of scope and declare it as a variable, or if you want to make a global variable, you can use the tilde. Oops, where's my tilde? Okay, a tilde AA. All right. So in this case, I'm just going to use a equals synth. And then, again, the brackets for the scope. And then the main thing it needs to work is the name of your synth def. In this case, synthy. Okay. So if I do a synthy, I should get a tone. And there you go. All right. And that's basically calling the synth def, playing the sine wave oscillator at a frequency of 200 out my synth. Let's turn that down a little bit. Okay, so this is an instance of synth. This is whatever, a green Frankenstein or a blue one, but it's one thing. You can also create several instances, and you just make sure you give it a different variable name. And following the same syntax, you can create several of them. Okay. So if I make a one and then I make another one, it just seems to get a little bit louder. Okay, and remember Command period to kill all sound. Okay, so you can make hundreds of these, and it just depends on your computer processing power, if you want. And it creates a thing that's quite flexible, and it's very efficient system that you can manipulate in real time, which is quite nice. Okay, so let's move on to the next bit of the sort of SynthDef approach, which is arguments. So arguments is just, I'll define as a specialized kind of variable. It is a namespace. It is a name that you can assign different things to, except it has the unique properties of being assignable from outside. So when I talked about arguments here, like freak, these are basically arguments that are built into this method signos, this ugen. I put a comma there, you can see these are the arguments that they've defined in that unit generator. So this, again, remember the score server environment. These are the things that the server side is allowing me from the outside to manipulate. Okay, and that's done in the form of arguments. And the way you define arguments in a SynthDef is you just use the word arg. Now, it does have to be in this order, args first, and then vars next, and then the rest of your code there. And args are now settable from the outside. So why don't we make an argument for this frequency? To make it a little bit more interesting, we'll call it freak. Okay. And then instead of this being hard-coded to 200 in my SynthDef, I can make that this argument. Okay, so the freak, you know, this is looking for a frequency, and this I've defined as here. I mean, you can call it something else so you don't confuse yourself, but that's fine there. So now if I send that now, Oh, and oftentimes with arguments, it's a good idea to have a default value. So let's make that 100 as a default. So if I send that, now if I just do this now, it's going to use my default 100. So if I create an instance of my synth it'll create a default of 100. And if I want to create another instance with a different one, so when you create with arguments, let me cut that sound. When you create with create a new instance of a synth, and you want to change the arguments on creation, you use this syntax. You do comma after the name, and you use this bracket notation or array notation. Okay, and everything in the brackets are the names of your arguments followed by the value you want to set it to. So I would call my name, and again, it uses a symbol notation, the backward slash, and you know because it turns green. I'll say freak, and then a comma, and then the value that I want to set that frequency to, which maybe would be in this case 300, say for example. Now you can continue to do this with all of your arguments. We only have one, but if you had multiple arguments, you can define them and then keep going, et cetera, et cetera. Okay. But in this case, we only have one argument defined here, frequency. And so if we create that one with the default 100, but we create another instance, now this B is equal to this instance of the synth, but we're going to initially start it with a frequency of 300. And there you go. Okay. So there you see my arguments are set from the outside after the fact, outside the synth def, and it makes it flexible. Now, you can actually also set it once your synth is going. So if I create an instance of that synth, I can set any argument while that synth is running. So I can go a.set and use this syntax, a.set, and again, parentheses for that scope. And then same as in this array here, you're going to create a list of argument name and the value. So I want to make that 250 then instead. See, it changes the A to 250. Okay, and then another thing I can do is I can free individual synths by doing that a.free. Okay, so again, to just sort of wrap up this little bit and summarize it a little bit, we have this server client architecture. And the synth really is sort of a mold or a blueprint that you set out. It doesn't actually make sound. So you create a definition, and then later on you create instances of that definition or objects based on that definition. And oftentimes you will assign that to a variable, so that now when I say A equals synthy, it's now A is actually a synth now. So I don't have to worry about this part anymore. And then SuperCollider has a built-in syntax to deal with the synth-def instance or synth relationship. So I can do things like set a synth, an instance of a synth. So notice that I use the variable a now to set frequency. And then I can do things like free. And there's other things you can do, but we'll focus on this because that's already quite a bit. Now you'll notice if I go, for example, to do this, and this happens a lot initially, if I go ahead and evaluate this line here, a.set, while A is not running, it says failure end set mode 1000 not found. That's just to say that I don't actually have an instance of the synth running. So I can't set A because set A doesn't exist yet. Okay, so that's an important thing just to understand conceptually, that we actually need to have an instance of the synth before we can set it. Okay. Whereas in this case, this example I showed is you're creating the instance of the synth at the same time you're assigning you're defining the argument. You're giving an argument a value. So you're changing something about the argument. That's not the default value. So that's why it's kind of important to have a default value, because if you were to do this without a default value, no sound would come out because it doesn't know what the frequency is supposed to be. Okay. So in this case, I'm creating a synth instance at the same time I'm setting one of the arguments at the same time. But that's not to say that afterwards I can still manipulate. Again, notice I'm using B to change it. Okay? Okay, so that'll wrap up the first sort of beginner's tutorial on SuperCollider and modular synthesis.